Hi, hello, welcome mga kabaiso. I am Marvin. Today, we will talk about the mapping. Mapping is a representation of the Earth's surface with its features and other things that you can see in the map. Now in this video, we will have to discuss how the maps are composed and what is the factors that we consider in making a map. For more details, let us have this presentation. More about mapping. But first, let us have the unit objectives for this presentation. At the end of this unit, the students are expected that they will be able to determine the land area survey, and also they also able to acquire a working knowledge in topographic maps, design and layout of horizontal or vertical curves in highway or railroad, and graphically determine Earth's mass and volume. And also, they would be able also to determine the use the appropriate methodology in various civil engineering construction. For the introduction for this presentation, that maps are a visual representation or expression of a portion of the Earth's surface. Features are depicted using the various combinations of points, lines, and standard symbols. Maps have been produced in graphics or hard copy form, that is, printed in paper or as table-based plastic material. Today, most of mapping data are collected in digital form and are then processed using the computer-aided drafting and design system to develop soft copy maps. Soft copy maps are stored within the computer, can be analyzed, modified, enlarged, and reduced in scale, and have their contour intervals changed while being viewed on the monitor of CAD system. Soft copy maps are indispensable in the development and operation of a modern land information systems and geographic information system. Cartography are the terms applied to the overall processes of the map production, includes the map design, preparing of or compiling manuscript, final drafting, and reproduction. These processes which apply whether the maps are graphics or digital. So means that today's use of the maps are evolved into the use of more than a land information system or the geographic information system, which will be dealt on the later part in our subject. We have here a representation of the Earth's, we call it one as the world map. This way is the map is representing the form of the continents or the landmass and water forms of the entire Earth. And maps can also be presented in a country map. We have here the map of the Philippines that represents all the land masses or islands that comprises the Philippine Islands. And also, it also can be used or done by the maps of entire province. Like for this one, the province of the Antique, they are representing all the uh, towns of the old province. Also, it can also present as the town map or the city map of a certain region. In this example, we have here the city map of Davao City. This is the way or the form of the land representation of the Davao City. Availability of maps and related information. Maps of a variety of different purposes prepared at scales varying from large to small in both graphics and digital form are prepared by private surveying and engineering companies, industries, public utilities, cities, countries, states, and agencies of the federal governments. Accuracy standards for mapping. The accuracy of any maps can be tested by comparing the position of points whose locations or elevations are shown on it which corresponds to the position determined by the survey of a higher order of accuracy. The USGS has developed its own standards to govern the production of the maps and other products provided through the National Mappings Program. The American Society of Photogrammetry and Remote Sensing has also adopted its own standards to govern the photogrammetric production of large-scale maps. It specifies standards for three levels of accuracy, class 1, 2, and 3. The American Society of Civil Engineers has also developed a set of standards for topographic mapping that are aimed primarily at large-scale engineering maps, in addition to suggesting accuracies for various map scales. They also provide standards for contouring, map symbols, abbreviations, lettering, and other factors important in mapping. As you can see here, these are the uh, standards for the maps. No? So standards, it will be dependent on what is the use of the map and what is where did you get the map. So to obtain the accuracy of the map, you have to compare both of the map with regards to its location and elevation and in the position of the maps. Say for example here we have here the topographic diagram or the topographic map of a mountain, the mountain of Sugarloaf. So you can see here the different elevation. So we have to compare this one to the other standard of the map if it is the same. If it is the same, so therefore there is accuracy in there. So this is how the map is represented. No? So we are here, this map is called the topographic map that each line here has a number that represents the elevation with respect to the mean sea level. Manual and computer-aided drafting procedures. Manual procedures utilize the standard drafting tools such as scales, protractors, compasses, triangles, and T-squares. CAD system employs computer program that special software and interface that electronic plotting device. With either approach, after deciding on a scale and other factors that control overall map design, a manuscript is prepared. When completed, all or final drafting is performed. In manual drafting, the manuscript is usually compiled in pencil. The completed version of the manually compiled manuscript is drafted in ink and scribed. So we have here a professional making a map. This is using T-squared and other drafting materials such as pencils that will be used in the drawing of the map. After that one, it is traced into a tracing paper and it has, after that one, the map will be finished. In drafting map with CAD, a soft copy manuscript is compiled in the computer and displayed at its screen as a work progress. CAD software provides instructions to the computer which basically duplicate manual drafting functions. A file containing the coordinates of points as well as the specific instruction on how to plot them must be inputted in preparation for mapping. We have here again a person who is making a map in using the CAD system. So the CAD system will generate or will show the data and plot the data on the screen or on the monitor as so seen in the side of this figure, and the screen will be displayed the data in a map form. So the maps there can be customized to fit on the scale and the how large is or how small is the map. So this is how CAD system in or making a map. Map design. Before beginning the design of the map, the following two basic questions should be answered. What is the purpose of the map and who is the map intended to serve? To achieve maximum effectiveness to map design, the following elements or factors should be considered. The first is the clarity. It relates to the ability of the map to convey is intended to information completely and unambiguously, meaning the map should be cleared. It is cleared in the way it represents to the one who will use. Second characteristic for this one is um, order. It refers to the logic of map and relates to the path that the user's eye would follow when looking at one. It is the how order is the map. It is the arrangement of the map. Next one is the balance. All elements in the map have weight and they should be distributed uniformly around the visual center of the map. So meaning balance, you have to take an important point at the mostly in the center of the map. Say for example, if you are focusing on the map of a certain school campus, you should focus your visual center on the school campus. Next is the contrast, relates primarily to the use of the different line weight and fonts of varying sizes. So contrast meaning you have to use the thickness of the importance, thickness of the lines or what is used, which gives the importance of the presentation of that map. Another thing is unity, refers to the interrelationship between the background, shading, and color of the map. And lastly, we have here the harmony, relates to the interrelationship between the elements of the map. So all of these factors should be considered when you are designing a map. So we have here a figure 18.1, the layout of a poorly balanced map that is shown on A. As you can see in figure A, you can have here a title not in the center and a legend not in the center but only occupies a small space, and the visual center is not located at the center or at the middle of the map sheet. And also the location of your scale is not in the proper way. So in figure B, a better layout for the map of the same map, it is represented mostly on the center. No? The visual center is found in the center, which is always a factor in the map, the title, and also the scale, and also the meridian arrow, and the legend. So take note that this is just a better layout. There are other layout available or that the map is followed not like this, but they also offer the same better layout, such as the meridian arrow is located at the topmost right or topmost left, and the scale is mostly located in this manner, and also in the legend is located at the sides. So it could be anything, no? That presents a better layout for the map. So we have here the title, no? You can spot the difference there, and also the visual center, the location or the main topic of the map, also located in the center. You can have this comparison in two different position. So we can have here the poor and the better position for the legend, and also for the meridian allo and scale. The position of that one take the difference of these two maps, the poorly and the more better way of the map layout. Map layout. The subject area of the map should be plotted at a larger scale that will be able to fit neatly in the borders without producing overcrowding. It should also be centered on the map sheet and, if possible, should be aligned to the edge of the map sheet coincide with the cardinal direction. Accordingly, the size of the and shape of the map sheet and size of the and shape of the area to be mapped, the orientation of the subject area on the map sheet and the map scale must be jointly considered in map layout. So we have here a sample of a map layout. So take note that most of these layout have this uh, visual center, which is the subject of the map. Mostly in this figure here, we have here presentation of the dimensions or the margins that are present in the standard map layout. We can have here the margin here at 1 inches or 1 inch at the left side, and the top side we have 1/2 inch, and for the right side margin we can have 1/2 inch also, and for the bottom margin we can have this 1/2 inch. And we have here for the space of the map title, we can have this 3 by 6 inches dimension of the side of the map, which is will not interfere the visual center of the map. Also take for that as a caution. Basic map plotting procedures. Manual plotting by coordinates. To plot the points by coordinates, the map sheet is first laid in a precisely on a grid pattern without a square with a unit square or appropriate size. Squares of 2, 4, and 5 inches are commonly used, and depending on the map scale, they represent 100, 200, 400, 500, or 1000 feet, or 50, 120, or 500 meters of distance. So each squares represent on that units mostly depending on the scale. But for plotting using CAD, fundamentally CAD system plot points and lines in a manner of similar to manual drafting techniques. However, they compared to manual map drafting, computer-assisted mapping offers advantages in increased accuracy, speed, flexibility, and reduced error. In order that digital map files developed during the CAD drafting procedure are suitable for the porting of GIS, and is important that well closed features are actually physically closed and in the mapping files. So take note that in this portion here, we know already the procedure for manual mapping using grids. And for plotting for cards, take note that for minute detail or small details, you should have achieved the physically closed in the mapping files. So take for example here, there are times that we are making a map or a figure in the CAD system. We can have this visually closed polygon, but actually the entity there is open. The end sides and points are not closed. So take note of that one. Compare for the polygon closed, physically closed polygon, all of the corners there are joined together, no? Unlike the visual closed polygon. Take note of that because in the map system or the CAD system, uh, due to very large scale, you cannot really detect if you not zoom in the sides of the polygon. So that is the difference between the visually closed polygon and the physically closed polygon. So in that part, highlighted there, the one who is not closed. It is visually closed, but actually that is not closed. Contour interval. Terrain type of map scale combining the to regulate the contour interval need to produce a suitable density spacing of contours. Rugged terrain requires a larger contour interval than gently rolling country, and flat ground mandates the relatively small one to portray the surface adequately. Also, in the map scale is reduced, the contour interval must be increased, otherwise lines is crowded, confuse the user, and possibly obscure other important details. For average terrain, the following large and medium map scales and contour intervals relationship generally produce suitable spacing. So this contour interval represents the representation of the ground. We have here from our reference book, we have here the suggested contour interval of with respect to the scale of the map. For English system, we have here a scale of 50. You can have a contour interval of 1 feet. That is very detailed. And for the scale of 1000, you have here contour interval of 20. For the metric system, you can have contour interval for 1 is to 500 scale. It is 0.5 meters. And also for 1 is to 10,000 scale, you can have 10-meter interval, 10-meter contour interval, meaning the what we are talking about is the spacing of your contours. So we have here what we are talking about, the contour interval. This is if we have here a mountain and the mountain is divided into in every 5 meters or 5 units. Then the representation of the contour there is by 5 from the lowest point, which is 100 units, to the second level we have 105, and to the third level, which is 110. So we have here the contour interval of 5 units. So this is what is meant by the contour interval. It will be depending for the scale of the map. So in this case, the contour interval is 5 feet or 5 units. I mean, so the spacing there for the profile, we have from the lowest elevation plus 5 units elevation. So that is the contour interval, and it will be represented in the map like the represented in the or the points pointed by the arrow. Plotting contours. Contours found by the direct method are sketched through the plotted points. Interpolation between the plotted points is necessary through a direct method. Interpolation to find contour locations between the points known elevation can be done in several ways. First is estimating. You have to estimate where should or the location of the contour. Number second is the scaling and the distance between the points of known elevation and allocating the contour points by proportion. Meaning in this part here you have to use the ratio of the actual distance, meaning the actual distance of the map over your actual height of the map reference. So on that portion we have the actual height, and the other portion is you have there also the other actual height, no? Is in relation to or equals to the scale proportion or the scale distance over your scale elevation. So this is how we do the proportion. Using a special third is using the special device called the variable scale, which contains a graduating spring. The spring may be stretched to make suitable marks fall on the known elevation. And number 4, using a triangle and scale. Contours are drawn only on the elevations, evenly divisible by the contour interval. Thus, the 20 feet interval elevation of 800, 820, and 440 are shown, but 810, 830, and 850 are not. So this to improve the legibility, every fifth line um, is made heavier so that 20 feet interval of the 800, 900, and 1000 lines would be heavier. So this is in this part here, we are talking about the contour, the intermediate contour, and the uh, index contour. So the index contour represents a heavier line, which is mostly presented in the 800, 900, and 1000, and the intermediate control are contour with a line thinner than the index. So we have here the figure 18.4, the interpolating using the engineer scale and triangle. The portion below here is the points where your engineer scale with relation to your triangle. So you should calibrate your engineer scale and your triangle into a reasonable scale proportion scale. So we have here the A and B as a reference point. Then you can get the value or location of your P, which is the contour to be found with relation to the uh, engineer scale. So if the engineer scale is pointing at 200, you just project that 200 by using the triangle to the appropriate location. So put the triangle on the 200 and you can get the location of your P, where the P is the point where your contour will go. Lettering. An important part of the contents of any map is a textual information. The title of all features, names, coordinate values, contour elevations, and other items must be clearly identified to produce a professional-looking drawing and a one that clearly conveys the intended information. A suitable style of lettering must be selected. Lettering should be carefully placed so that it is clearly associated the item it identifies and so the letters do not interfere with other texture features being portrayed. Text should take precedence over line work if necessary. Lines should be broken with text is placed as this improves clarity. So in this part here, when we are talking about lettering, so there are several fonts that we have to use. So mostly this is a fonts which is clearly visible or easy to read in the maps. For smaller parts, the manual drawing of the or drafting of the maps, they can use the template letters for their uh, fonts and letterings. Cartographic map elements. Notes, legends, bar scales, meridian arrows, and title blocks are essential cartographic elements included in maps. Notes cover special features pertaining specially of the particular map. Cartographic symbols and different line types are commonly used to represent and portray different photographic features on maps, and legends are employed to explain the meaning of these symbols and lines. So we have here the example of the legends or cartographic features or legends that are commonly used in the maps. Say for roads, they are mostly represented by a line, two lines or a broken lines. Or for trails, they are mostly represented by a broken lines. And for railways or railroads, they are represented by a line and its perpendicular lines on it. And for tunnels, they are represented by a broken line like a bridge, but only it use a broken line. And for fence, there are different kind of representation of fence in the actual maps. For boundaries, these are mostly represented by a line or a semi-broken line. Another representation of our legends in the maps, we can have the bridges, the Mars. These are land with plenty of water. The woodlands, they are considered to be forest or semi-forest. The trees, we have pines, and buildings and other features in the ground that is represented on the map. So these are the examples of uh, cartographic elements that we'll be considering in the map. Some, the scale of the map should preferably be presented as both the representative fraction of the graphical elements. Meaning for this scale, the scale was represented like this. So we have here the equivalent line of the map. When you measure that one in the actual, that would be the representation of the true distance in the map by using the scale. Meaning for this first drawing, we have here 0 to 100 miles. So 100 miles should be the same length represented in the legend, and it is transferred to the map. So it will be give the user that the 100-mile is somewhat location on, or somewhat that is the distance found in the map. Every map must display a meridian arrow for orientation purposes. The arrow should be so large or so elaborate that it becomes the focal point of the sheet. Geodetic grid or magnetic north may be shown. Often, the true meridian arrow is identified by the first or by a full head and a full feather, and a grid and or magnetic arrow are by half head and half feather. So we have here the representation of mostly of a meridian arrow. So these are the, for other maps, they also represent the true north, the geodetic north, and the compass north. But for most general use map, they only represent a meridian arrow that represents like this. The title block should state the type of map, name, property or project, and its owner or user, location or area, date completed, scale control interval, horizontal and vertical reference system used, and for property survey, the name of the surveyor and with his or her license number. Additional data may be required on special purpose maps. So we have here a sample of a title arrangement or the title block or arrangement in the title block. So we have here the name of the location and also the surveyor, and it should be have the data for how, when it was done, and also it also bears the signature of the one who performed the survey. Drafting materials. Polyester films and tracing and drawing papers are the materials commonly used for preparing maps in surveying and engineering offices. Polyesters such as mylar and by strong, durable, and waterproof. In addition, they are take pencil ink, stick up items, and withstand erasing, so they are ideal for manual drafting. Tracing paper are available in a variety of grades, and good ones are also suitable. Take pencil ink and stick ups and endure some erasing. Both mylar and tracing papers are transparent, so blueprints can be made from them. Papers of different types and grades are used for printing maps made with CAD system. When CAD is used, the paper quality can be relaxed somewhat because erasing, stick-ups, lettering, etc. will not be necessary. If accurate measurements are extracted from the maps, then material with good dimensional stability should be used. So we have here in a figure, we have here the figure of a tracing paper. This tracing paper and also the polyester film, these are materials that are transparent that will be used in the drafting of the map. For final uh, drawing of the map, they use this tracing paper or polyester film. Automated mapping and computer-aided drafting system. Digital computers have had a profound impact in all areas of life, and surveying and mapping is certainly no exception. Automated mapping and computer-aided drafting and design systems have now become commonplace in surveying and engineering offices throughout the world. Generic CAD systems developed for general drafting and engineering work are widely used in map drafting. In addition, special automated mapping systems have been designed specifically for surveying, mapping, and GIS works. CAD system enables operators to design and draw manuscript map in real time using the computer. A visual display of the manuscript can be examined on the monitor as it's being compiled, and any additions, deletions, or changes can be made as needed. A TIN or is a digital terrain model, which is also commonly called the digital elevation model of the Earth's surface. The DTM shows only topographic features of the Earth and is devoid for any vegetation or structures that lie on the surface. A DTM can be created with a TIN and by locating spot elevations in grid, although the format is more prevalent in practice. We have here a figure 18.8, the TIN or the triangulated irregular networks. This is the representation of the maps. And on the other side, we have here the contour derived by automated mapping. You can see here the difference in representation because it has in TIN, it represents most of the triangles, and in the AM or the automated mapping, you can see the representation there is it represents a contour of the area. So two of these representation are preferable depending on the use. So mostly if for rendering purposes the TIN model is more preferable, and for contour purposes you can have the automated mapping is used. TIN models of Figure A note that roadway edges were defined by break lines and in Figure A, so that is the triangulated irregular networks representation of a data. Here is the also the example of the automated contouring of TIN. So we can have here this at the points where the edges of the triangle has its elevation, and that elevation is represented, it's given in the data. So the way they compute the contour or location of the contour is by using the equation that this 2.6 over 2.9, this is the the scale distance, the scale distance over the scale elevation is equals to the change in length over the actual distance in the uh, real map, or it is the proportion of the scale distance and the actual portion of the actual ground distance. So it will gives you the change in length, which is equals to 83.78. So this is other way or presented of three-dimensional perspective grid. No? So using similar in the TIN. So this figure here is in perspective perspective view. This guy here is plotting or encoding a coordinates for the computer-aided drafting and design workstation. It inputs the data on the map and also he creates a model for the data. Here are the representation of the different types of map that were used with the aid of the CAD system. So one here is the um, subdivision of map compiled by automatically by computer driven plotter. And also for this other side we have the CAD system. The the engineering design map prepared by a CAD system. So these are maps produced or prepared by the aid of computers. Impacts of modern land and geographic information system in mapping. Land information system, geographic information system, and automated mapping and facilities management system all requires enormous quantities of position-related land data. From this information, maps and other special-purpose graphic display can be made and analyzed. For example, the typical LIS or GIS may include attribute data such as political boundaries, land ownership, topography, land use, soil types, natural resources, transportation routes, utilities, and many others. From the stored information, a user can display a map of each attribute category or by layer, and a screen or several layers of the data can be merged to produce combination maps. This merging or overlaying concept greatly facilitates data analysis and aids significantly in the management and decision making if printed maps of any selected layers or combinations are desired. They can be produced rapidly using automated drafting equipment. So we have here the system of the GIS or Geographic Information System or the LIS or any computer related in use in the maps. So they have the information of the necessary data that comprises on the portion of the map or the actual data on the map. They are merged into one system. And on that merging you can separate the in GIS you can separate the different uses, no? The roads, the land use, boundaries, hydrography, elevation, or the main map. So these are just example, no? You can just add more for the GIS use or land or LIS. So the concept there is to have the overlay of the data on the image based, and overlaying then it will produce different kind of colors for the data to present. For the present of that one, we can have here the actual layering of the data of a certain map, and it will produces an image that might look like this in the system, or you can print an image output like this from a GIS system or the CAD system. Sources of errors in mapping. Sources of errors in mapping, it includes errors in the data used for plotting. So take care of the data. So be careful of the data. It may lead to an erroneous plotting. Error in scales used for laying out lengths and coordinate values. Errors in laying out grids for plotting y coordinates. Using a soft pencil and one will blunt a point or for plotting. various variation in the dimension of map sheet due to temperature and moisture. Take note that most of the date error in mapping comes from the erroneous data and also with the wrong type of equipment that are used. Say for example, the pointed, no, it will be confusing that if you are using pointed and there is a blunt point over there, so it will be a misrepresentation of the data. Mistakes in mapping. Some common mistakes in mapping are the selecting an inappropriate scale or contour interval for the map, failing to check grids by measuring diagonals and not checking points plotted from the coordinate by measuring distance between them, using the wrong edge of the engineer scale, making a north arrow too large or too complex, neglecting to identify the meridian or reference that is geodetic grid, magnetic, etc., omitting the scale or necessary notes, failing to balance the sheet by making a preliminary sketch, drafting the map on a poor quality medium, failing to realize that errors are also magnified when the map is enlarged electronically or photographically, and lastly, the AM and CAD system without sufficient prior training. So most of this one who will make the map, they are trained first of all, no, in how to use the computer or the how to make the map, and also aside from train, they are actually a course in drafting that specifies in the drafting of the maps, especially when making the maps, no? Manual or computerized, they have a training. So to enable them to obtain a correct output or correct mapping data or mapping design or anything that relates to map, they have a training important. No? Aside from schooling, they have training. And this will conclude for this meeting. So for mapping, uh, it is very useful in surveying for the upcoming chapters because we will deal about maps. And in practice, it is very useful because almost all of the survey uses maps. So thank you for listening. Thank you for watching my video. This is Marvin signing off. See you on the next video.